In this video, we're going to talk about proving if two functions are inverses. So in the last lesson, we talked about inverse functions, and this time I want to talk about having to checking to see if two functions are inverses of each other. We can do this through something called function composition, which it's f of g of x and g of f of x. And if both of those are equal to x, then our two functions are definitely inverses of each other. So this can seem kind of overwhelming. There can be a lot of math involved in this, but if you take things one step at a time, it's really not too bad. Let's look at example number 1 here. We have f of x is x plus 4, and g of x is x minus 4. So the first thing I'm going to do here is do f of g of x. So basically what that means is I'm going to write down what I'm doing first, f of g of x. What I'm going to do is take my f of x equation and replace the x with whatever g of x says. So here we see x plus 4. Well, my x, I'm going to replace that with x minus 4. Yes, and then plus 4. So here is the g of x right here, and then here is the rest of the f of x that was outside it. Now all I'm going to do is simplify. I don't have anything special going on. There's no distribution. So for all intents and purposes, those parentheses don't mean anything. So I've got x, and then negative 4 plus 4 is 0. So I just have equals x. So that part's done. Now we're going to do the opposite, g of f of x. G of f of x. So I'm going to take my g of x equation, and I'm going to replace the x here with whatever f of x is. So in that case, it'll be x plus 4. And then I'm going to finish my g of x, which is minus 4. Same thing happens. Those two 4s cancel out, and I end up with x. So f of g of x equals x, and g of f of x equals x. Therefore, these two are inverses. Now that little pyramid of dots right there, that's math shorthand for the word therefore. Let's take a look at B, which I'm sure is a little bit scary. Let's start off with f of g of x. All right, my f equation starts with 3 times x. So my x, I'm going to replace with my g stuff. I'm going to replace with that 1/3 x plus 1/3. 1/3 x plus 1/3. And then I'm going to finish that equation with the negative 1. Now, I know a lot of you are going, Mr. Clark, there's fractions, you're freaking out. Not a big deal. Look at how nicely this works out. 3 times 1/3 is 1. So I really get 1x. Plus 3 times 1/3 is 1 again. And then minus 1. It's not too bad at all. Those two 1s cancel out, and I'm left with just an x. I'm not going to do you guys wrong. Let's do the opposite of that. G of f of x. I've got 1/3 times 3x minus 1 plus 1/3. Okay? 1/3 times 3 is x. 1/3 times negative 1 is negative 1/3. And then plus 1/3. Our thirds cancel out. And we end up with just an x. So you'd be surprised what works out really nicely for you. So in this case, once again, since they both equal x, therefore they are inverses. Now let's take a look at C. Ooh, this looks like it might be scary. Let's see what happens. F of g of x. F of g of x. So 1/4 of x, which is now the cubic root of 4x, and that's cubed. Okay, well, this looks a lot worse than it really is. Let's check it out. So we're going to do a little bit of PEMDAS here. We've got exponents. Well, this exponent and this third root cancel each other out. So we get 1/4 of what's inside of there, 4x. And 1/4 times 4 is 1. So I end up with just an x. Let's do it the other way. G of f of x. G f of x. I'm going to take the third root of 4, and then in here is 1/4 to the x cubed power. Oh my goodness. Let's check this out. 4 times 1/4 is 1, right? So this ends up just being x cubed. And the third root of x cubed is just x. Worked out beautifully. So g of f of x is x, f of g of x is x. That's a lot of x's in one sentence. Therefore, they're inverses. All right, let's move on to D. Cool. All right, f of g of x. F of g of x. So 1/2 times, all right, we've got a 2x minus 4/3 plus, 3/4. Okay, let's distribute that 1/2. So 1/2 times 2x, that's an x. So far, so good. 1/2 times negative 3/4 is, let's see, 2/3 plus 3/4. And I'm going to go ahead and do that fraction math. Whoops. Go ahead and do that fraction math for you. That means that our equation simplifies to x plus 1/12. Now, is that just an x? No. And our definition says if they're going to be inverses, it's got to equal just x. So they're not inverses. Therefore, not inverses. If you get to a point where you're at the end of one of these compositions and it doesn't equal x, then clearly they're not going to be inverses of each other.